CCI, Crash Course Instrumentation, presents episode number 73. Loaded dividers and amp, meter loading, why readings change. Standing credit. Thank you to Tony R. Capalt and the open source community for the ModEL project. Hook, your 8-volt divider suddenly reads 6.1 when you clip the meter. Today we explain why, in plain words, and how to design so the reading stays where you want it. Roadmap. We'll define a divider, show what loading means, explain how meters change circuits, give a quick design recipe for loaded targets, and end with 2 sanity checks. Terms in plain English. Voltage divider. 2 resistors in series across a source, using the series share of current to create a fraction of the source voltage at the middle point. Load. Anything connected to that middle point that draws current. DMM. Digital multimeter, a voltmeter, inside a DMM has very high resistance. An ammeter has very low resistance. Insertion resistance, the effective resistance a meter adds when you connect it. The divider in words. Picture 2 resistors in series from the positive side of a source down to the negative side. The connection between them is your output node. With nothing else attached, that node is a fixed fraction of the source set by the resistor values. What loading really means? When you attach a load to that output node, the bottom resistor is no longer alone. It sits in parallel with the load. The bottom leg's effective resistance drops, the divider ratio changes, and the output voltage sags. Meters are loads too. A voltmeter connects in parallel with the point you measure. Even a 10 megaohm meter steals a tiny current. With very large divider resistances, that tiny current is not negligible. An ammeter connects in series and adds a small resistance. In low resistance circuits, the added resistance can change the current you meant to measure. Designing a divider for a known load recipe. 1. Know your target. Choose the output voltage you want at the node, with the load attached. 2. Model the load. Treat the load as a single resistance R load tied from the node to the negative side of the source. 3. Pick the divider scale. Choose a total divider current about 10 times the expected load current at the target voltage. That 10-to-1 rule keeps sag small without wasting too much power. Use another ratio if power is tight, but know the trade-off. 4. Compute the bottom leg. The bottom leg is your bottom parallel of R bottom in parallel with R load. You want R bottom parallel to produce the target fraction. Start by picking a comfortable R bottom that is similar to R load, or a bit smaller. The parallel result will be smaller still. 5. Compute the top leg. Use the divider fraction in words. Output equals source times bottom parallel over top plus bottom parallel. Solve for the top leg so the fraction lands on your target. 6. Check the meter. If your voltmeter is 10 megaohms, put that resistance in parallel with the load as a final check when readings matter. No math insight you can remember. If the attached thing is hard to push, small resistance, it will pull the node down. If it is easy to ignore, huge resistance, the reading will stay close to the unloaded value. Make the divider current much larger than the load current to make the load easy to ignore. Quick estimate example in words. Suppose your source is 12 volts, your load is 12 kiloohms, and you want 6 volts at the node under load. If your meter is 10 megaohms, the meter barely matters. If you used 1 megaohm legs, the load current is about half a milliamp, and the divider current is about 12 milliamps, 24-to-1. So the sag is small, and the design is comfortable. 2 fast checks. Loop, KVL. Drops across the top leg, plus the bottom parallel must equal the source. Node, KCL. Current into the node from the top leg equals the current taken by the load, plus the meter, plus the bottom leg. Historical nugget. Early galvanometers in the 1800s, heavily loaded circuits. Sensitive coils needed lots of internal resistance. Modern DMMs are far gentler, but the same principle applies. The act of measuring can change the thing you measure. Recap. A divider is simple until you attach something. Loads and voltmeters sit in parallel with the bottom leg and pull the node down. Ammeter measurements sit in series and add a little resistance. Design for the loaded case, and your readings will match reality. Thanks to Tony R. Coupault and the open source community. If this helped, like and subscribe to Crash Course Instrumentation. Next, episode 74 wraps the arc with mixed sources and practical series parallel banks.